Here is a frequency distribution table summarizing the ages of the 89 Academy Award-winning actresses. In this problem, we're not given the raw data, or the sample data, and we're being asked to find the mean, standard deviation, and variance of the sample. The purpose of this video is to show you how to use the calculator to find the mean, standard deviation, and variance of this frequency distribution table. Now, it should be noted here that the calculator and the formulas that are used for the calculator to do this problem, those formulas are only going to give us approximations now to the actual values of mean, standard deviation, and variance. To do this problem, we need to go through these list of steps. In step 1, we're going to calculate the midpoints for each of the classes using the formula lower class limit plus upper class limit divided by 2 for each entry. Then we want to input the midpoints and frequencies in list 1 and list 2. So we're going to open up the calculator's list environment by pressing the stat button, then edit. Then we're going to input those midpoints into list 1 and the frequencies from the frequency table in list 2. Let's go ahead and do those steps now. Okay, let's open up our calculator's list environment by pressing Stat Enter. If there's any data in your calculator's list 1, you'll need to erase that by using your arrow key to arrow up and over until your cursor is highlighting L1, and then press Clear, Enter. So now we want to enter in the first class midpoint. So the first interval is the interval from 20 to 29, and the first class midpoint would be the lower class limit plus the upper class limit of that first class divided by 2. And we can repeat this process for each one of the classes, or we can be smart about it and just add the class width to this midpoint 24.5 to get the next class midpoint. So we keep on repeating the process of adding class width to get the next class midpoint. Okay. And remember, for midpoints, we do not round midpoints. Do not round class midpoints. Okay, let's go ahead and use your arrow key to get over to list 2. Now we want to type in the frequencies here. Okay, once we've got those two things done, we need to now exit out to our home screen. So we want to do that by pressing the second button followed by the mode. This gets us back to the home screen. Now let's draw up the one variable statistics command. To do that, press the stat button, then arrow over to the calc drop down menu. One variable statistics is the first function listed there, so press enter. This gives us a pop-up screen. We want to make sure that our list is L1, and we want to make sure the frequency list is L2. If L2 is not already sitting there, you can enter it in manually just by pressing second 2. So then use your cursor here to calculate, arrow down and press the calculate button. So now we've got values for the mean and the standard deviation. Let's go ahead and write those down. The mean is 36.2 years, and the sample standard deviation given by SX is 12.9 years. You can see I typed in the sample variance here. It's 165.7 years squared. And how can I get that value from the calculator? Well, you've got to press the vars button. Then press 5 for the statistics variables. Press 3 for the sample standard deviation. This will copy and paste the symbol for sample standard deviation over to the calculator's home screen. Now press the x squared button and enter. So now we've got the three values of mean, standard deviation, and sample variance. And in practice, you may or may not have access to the actual raw data, but we have it here. And I want you to notice that well, in previous video we calculated means, sample standard deviation, and variance for this data set, and there the values are. Notice the mean here is equal to the mean over here. So we've got two We've got a good approximation for the mean, but the approximation that we have for the sample standard deviation is pretty far off. The true sample standard D is 11.7, and the sample variance is 137.7, which we're pretty far off from that as well. So once again, I wanted to let you know that these formulas that we're using to give values for mean, standard deviation, and variance are only going to be approximation of these actual values, and so they won't always be equal. Okay, let's show you folks how to do the problem with the TI-83. Let's go ahead and review steps 1 through 3. We want to calculate the midpoint for each of the classes using the formula lower class limit plus upper class limit divided by 2. Then we want to input the midpoints and frequencies into list 1 and list 2. So we're going to open up the calculator's list environment by pressing Stat, then Edit. Then we're going to input the midpoints in list 1 and input the frequencies in list 2. So let's go ahead and do that much. Press Stat Enter to open up the calculator's list environment. And if you may have data in list 1, if you do, you want to clear that out. Use your arrow keys to arrow over and up until your cursor is highlighting L1, and then press Clear, then Enter. Now we want to enter in the class midpoints. So the first age class was 20 to 29. That means the class midpoint will be 20 plus 29 divided by 2. Notice I'm using parentheses around the sum, 20 plus 29. When I hit enter, the calculator does the arithmetic for me, and we get the first class midpoint as being 24.5. Now remember, we do not want to round class midpoints. Don't round class midpoints. So now we're going to go ahead and repeat this process, use the formula for class midpoints until we have all 7 midpoints. Or we can be a little bit smarter about it and just add the class width to 24.5 to get the next class midpoint. So the class width is found by subtracting any 2 consecutive lower class limits, so you can see the class width is 10. So now let's go ahead and add 10 to 24.5 to get the next class midpoint. So we'll keep on adding 10 till we get all the midpoints. So now we're ready to enter those frequencies into list 2. Use your calculator's arrow button to get yourself into list 2. And then we want to, go ahead and enter in the frequencies. Okay. Now we want to go ahead and proceed through with steps 4 through 7. The next thing to do is calculate the mean and standard deviation. We want to exit out of your calculator's list environment by pressing second mode. The second button and then the mode button. This will return us back to the calculator's home screen. Now we want to access the calculator's one variable statistics command. So remember how to do that. Press Stat button. Arrow over to the Calc drop-down menu. One variable statistics is the first entry, so it's just press the 1 button or press Enter. This will copy and paste the one variable stats command over to the home screen, and we need to enter in L1 and L2. We need to tell the flashing cursor L1, comma L2. So now we're going to use the 1 button. So press second 1, and this will put in L1, and then press the comma button, the dedicated comma button, and then we want to tell the calculator L2 here. So we're going to use the 2 button, press second 2. So now we're feeding into the one variable statistics algorithm list 1 and list 2. Press enter to execute the algorithm, and you can see we have our sample mean and sample standard deviation. Sample mean is 36.2. Sample standard deviation is given by Sx, and that's 12.9. And to get the sample variance, we want to square that value. So the way to do this, we want to press the vars button. Press 5 now to access the statistics variables, and Sx is number 3 on the list, so press 3. This will copy and paste the symbol Sx, the sample standard deviation, over to the home screen. Press the x squared button, followed by enter to square that value. So now sample variance, the estimation for that is 165.7, and that's of course years squared, and the units on the mean are in years, and the units on the sample standard deviation are also in years. Okay, so that's how you do it with both calculators. And I want you to notice that while in previous video we calculated means, sample standard deviation, and variance for this data set, and there the values are, notice the mean here is equal to the mean over here. So we've got a good approximation for the mean, but the approximation that we have for the sample standard deviation is pretty far off. The true sample standard D is 11.7, and the sample variance is 137.7, which we're pretty far off from that as well. So once again, I wanted to let you know that these formulas that we're using to give values for mean, standard deviation, and variance are only going to be approximation of these actual values, and so they won't always be equal.